The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or fall on a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. Potentiometers are a type of variable resistor. Some variable resistors, like thermistors, change resistance when the temperature changes. Other variable resistors, like photoresistors, change their resistance with changes in light. Potentiometers change their resistance when you turn a dial. Potentiometers are everywhere in electronics projects because they're an easy way to adjust the resistance and voltage in a circuit. They can be used to adjust the volume of an amplifier, control motors, or adjust the contrast of an LCD display. In this video, we're going to learn how potentiometers work, how to read analog voltages, and how to use the stereo monitor.
Potentiometers come in a variety of shapes, sizes, and resistance values, but they all pretty much do the same thing, and that's change resistance when you turn the dial. Most potentiometers have 3 pins, a center pin and 2 outer pins. The 2 outer pins are connected by a piece of resistive material that forms a semicircle inside the body of the potentiometer. The center pin is connected to a wiper that rotates when you turn the knob. The wiper slides along the resistive material, so depending on the position of the knob, there is either more or less resistive material in the path of electrical current, so the resistance changes. Normally you connect one of the outer pins to positive and the other pin to ground. The center pin is the tap that provides the varying voltage. If one outer pin is connected to 5 volts and the other to ground, the center pin will vary between 0 and 5 volts as you turn the knob. This is a type of voltage divider. Voltage dividers are used to step down or reduce the voltage in a circuit. A voltage divider consists of 2 resistors in series. One resistor is connected to a voltage source, and the other resistor is connected to ground. We can think of the voltage divider as having an input voltage and an output voltage. If we use the Arduino's 5-volt pin to supply the voltage, the input voltage will be 5 volts. The output voltage is taken from a wire connected between the 2 resistors. It'll be between 0 and 5 volts, depending on the resistance of the 2 resistors. If R1 and R2 have the same resistance, the output voltage will be exactly half of the input voltage, or 2.5 volts. If R2 has a very high resistance, the output voltage will be very close to 5 volts. If R1 has a very high resistance, the output voltage will be close to 0. Potentiometers work the same way that voltage dividers do, except in a potentiometer, the resistances of R1 and R2 change when you turn the dial. This creates a variable output voltage that you can set to any value between the input voltage and 0 volts. This is the schematic symbol of a potentiometer. It looks like a resistor symbol with an arrow pointing to it. The arrow pointing to the resistor represents the wiper on the center pin. The ends of the resistors represent the 2 outer pins. Let's use the Arduino to read the output voltage from a potentiometer. To measure voltage, we need to connect the output pin of the potentiometer to one of the Arduino's analog pins. The Arduino has 6 analog pins, labeled A0 to A5. Any of these pins can measure voltage using the analog read function. The analog read function only needs one argument, the analog pin number you want to read the voltage at. The Arduino can only measure voltages between 0 and 5 volts. This voltage is measured by the Arduino's analog to digital converter, or ADC. The ADC converts the analog voltage measurement to a number between 0 and 1023. A 0 voltage has an ADC value of 0, and a 5 volt reading has an ADC value of 1023. Voltages between 0 and 5 volts are mapped to values between 0 and 1023. The analog read function returns the ADC value of the analog pin it's measuring. When we say that a function returns a value, we just mean that it outputs a value. Let's look at what the analog read function returns when we connect the potentiometer to the Arduino. Wiring the circuit is pretty simple. Plug your potentiometer into a breadboard, then connect the left pin of the potentiometer to the ground pin of the Arduino with a jumper wire. Connect the right pin of the potentiometer to the Arduino's 5 volt pin. And connect the center pin of the potentiometer to analog pin A0. This sketch will display the values returned by the analog read function on the Arduino's serial monitor. The serial monitor displays serial data from your Arduino on your computer monitor. We'll be using it in this course a lot to display the output from sensors and other modules. To use the serial monitor, we need to initialize it in the setup section with the function serial.begin. The serial begin function only takes one argument, the serial baud rate. Baud rate is the speed the data is sent back and forth between the Arduino and your computer. In the serial monitor window, there's a drop-down box with the different baud rates you can use. Whichever baud rate you use, make sure the number in the drop-down box matches the number in the serial begin function. In the loop section, we create a variable called raw value and declare it an integer by putting int in front of it. Up to now, we've only created variables at the top of the sketch. But here we're creating a variable inside the loop function. This is known as a local variable. Variables that get declared at the top of the program are called global variables, and they can be used anywhere in the program. But local variables can only be used inside the function that they're declared in. Here we're setting the raw value variable equal to the analog read function. We want to read the voltage at the center pin of the potentiometer, which is connected to analog pin A0. So we put A0 as the argument in here. This tells the Arduino to use the analog read function to measure the voltage on pin A0 and store the value in the variable raw value. Now we just need to tell the Arduino to send that value to the serial monitor. For that, we use the serial.println function. The serial.println function can print numbers, strings, or variables. It only takes one argument, the stuff you want to print. To print numbers and variables, you just put the number or variable inside the parentheses. To print strings, you put quotation marks around the text you want to print. We want to print the voltage reading from the potentiometer, which is stored in the variable raw value. So all we need to do is enter raw value inside the parentheses here. Next, we delay for 100 milliseconds, which will slow down the output a little bit. Let's see what this looks like in the serial monitor. I'm going to upload this to the Arduino now. The sketch verified fine. And now it's uploaded. To open the serial monitor, click this magnifying glass icon here. You can see a bunch of numbers getting printed out here. These are the raw ADC voltage values that are being measured at pin A0. Turning the potentiometer all the way to the left drops the raw value to 0. and turning it all the way to the right increases it up to 1023. This is cool, but it would be nice if we could print the actual voltage instead of the raw ADC values. To do that, we're going to need to convert the raw values into voltage using some simple math. We already have a variable called raw value to store the ADC readings from analog pin A0. But we need to do some math with those readings, so we'll create another variable called voltage, which will store the results of our voltage calculation. This time though, we're going to declare the voltage variable as a float. Declaring a variable as a float tells the Arduino that the number stored in the variable will be a floating point number. Floating point numbers have decimal points, like 1.3, 2.46, or 8.27. Now we're going to set the voltage variable equal to a formula. Raw value times 5 divided by 1023. 5 divided by 1023 is a conversion factor. It means that for every 5 volts, there are 1023 raw ADC units. To convert the raw ADC values to voltage, we just have to multiply the raw value variable by the conversion factor. Now we print the voltage variable to the serial monitor with serial.print. There are 2 versions of serial print: serial.print and serial.println. Serial.println prints the stuff inside the parentheses, then goes to the next line. Serial.print prints the stuff inside the parentheses on the same line. So here, we'll use serial.print to print the voltage variable. Then we'll use serial.println to print the word volts. Let's see what this looks like. So now we're getting the output from the potentiometer in volts instead of raw ADC values. The code for reading a potentiometer is pretty much the same code you would use to read any sensor that outputs an analog voltage. First you get the raw ADC value with analog read, then you do some math to convert the raw ADC value to the units you want. After that, you just print it to the serial monitor or to an LCD. You can also use the raw ADC values in a function to make the Arduino do different things depending on the reading from the sensor. We'll see how to use sensor readings to control the Arduino's output later on in the course. But in the next video, we're going to learn how to use push buttons and switches to control what the Arduino does.
SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.